you remember from our previous episode, we talked briefly about what Node.js is, compared it to a sort of real-world example, and for good measure, in a Node screencast, we looked at some Ruby code. In this episode, we're going to actually run some Node. We'll assume you've already installed Node. If you haven't and you need help, don't worry, we're going to do an episode on that in the future. But in the meantime, you can check out the NVM project, which will help you get up and running on Node in no time. All right, so we're back at our command line. We can tell that Node's installed because if we run node-v, we get the version number there. Now, the absolute simplest way to run and start using Node is to just type Node at your command line, and that'll drop you into the Node REPL. REPL, of course, stands for read eval print loop, and that's pretty common throughout the world of computer programming. And Nodes in particular is actually a core part of Node that you can load into other programs if you want, and that typing Node just drops you into it. We're not going to explore embedding it into other programs right now, but we are going to look at using it for some things. So what can I do with my Node REPL or Node console, however you want to call it? Pretty much whatever you want to do. It does just execute arbitrary JavaScript and give you back the return value. So I can, for example, put in 42 and it says 42. I can look at my variables that are in scope. For example, there's console, which has some useful functions on it. And if you've done browser-side JavaScript, then you're probably aware of the console.log function. And there you can see it gives its output. You can have a look at the process variable, which contains useful information about your running process, including your environment variables. This is where you would get those. You can even create new variables like that and then inspect them if you want to. It just runs JavaScript. That's all it does. You can, when we get to the point where we're pulling in other modules or packages, you would be able to do that here and experiment. And so that gives you a really nice way to play around with your code without running it in the browser, for example. Now, when you're all done, you just go ahead and type, oh, whoops, it's not exit. To get out of the Node REPL, what you want to do is a double Control-C. And that'll take care of that, and you're back at the command line. All right, so the interesting way of running Node is to do so through code that's in files. And so we're going to just do a quick example of that. And this will just simply acknowledge our heritage that we come from in the programming world and do a simple console statement. Now we want to run that, and to run a file full of Node code, or it's just JavaScript, you would just run Node and then the name of the file. And look at that, we see our output and everyone is happy. So one key takeaway here, notice that when we ran the Node program, it did our console statement and then just exited. This program didn't stay running, and turns out that to do things like handle web requests, the program does need to stay running. So we're going to talk about that in just a little bit on why this program exited and why others would keep running. All right, then let's look at an example that is slightly more interesting. We're going to create a new file here, and we'll just call it server.js, and then go on over to the Node.js website, and they have an example here on how to set up an HTTP server and then listen for requests on it. So we'll just take that and pop it right into our file. And then we can add a few spaces just to help us separate some ideas out here. And then there's one last little tweak we need to make, oddity of where I'm running this. So let's just pull that out real quick. And then if we wanted to run this server, we would do so the same way we did with our hello program, but this time we'd of course specify the server file's name. And we can see that our console statement happened, suggesting that all this ran too. And our server is up and running. And note that the program did not exit. We're not back at a command line. We can't actually type new commands here. We'll get to that in just a second. First of all, let's see this thing in action. And to do that, we just pop over to our browser, open a new tab, and we'll put in the URL for this. And of course, that's running on a pretty elite port. And there it says hello world. Pretty cool, huh? So let's come back to the code then and actually break down what's happening here. In the very first line, you see we have var http equals require http. Var, as you know, is how you declare variables in JavaScript. So we're just declaring one named http. Well, what's the business with this require statement? Well, JavaScript didn't really have a defined way of pulling in code from other files in non-browser environments. If you're in a browser, you can just throw in another script tag if you want to. But now that we have JavaScript running quite comfortably outside of a browser, we needed some way to deal with multiple files that was better than a script tag. So some folks got together and put together CommonJS, which is one proposal for handling this problem. And definitely go to this website and read the material there. It's quite relevant to us as Node programmers because that is what Node implements for getting code from other files. So require then is a built-in Node function that loads up an external module. So HTTP then is one of the core Node modules. You don't have to do anything special to get access to it. This require statement then loads the HTTP module, and since it is a function call, it has a return value, and we put that return value into the HTTP variable. Now there's nothing special about that name. Indeed, we could have named it Teal'c. We don't though, because HTTP is much more descriptive since it matches the name of the module exactly. Now the HTTP module has a function called createServer, which we can see right here. We're calling that, and we pass it a function. Skip over that real quick. We can see the end of the call right here. Now the way this code was formatted on the website was for just fitting it into the fewest lines possible, but we're going to break that apart real quick just to get a better picture of what's going on. So here you can see we've pulled that request handler out into its own variable, and now our line looks like this. And one more change that we could make is to do something a little bit like this, pulling the server itself out into another variable, and then we can just call listen on that server thing. So let's look through what each of these components does. And before we do that, we should probably fix our syntax error there as well. Breaking out the code this way really helps us see what the different parts are. We've already talked about HTTP, so we won't belabor that point. But next we have this handler. It's just a function. There's nothing special about this function. It takes two parameters, one rec, one res. We'll talk about what those objects will be in a minute, but it's just a normal function. It could have been anything. And then when we call our create server, we pass in that handler and we stash the result of that in server. So we've done a bunch of initialization here, and then we finally just call listen on server, giving it a port number to listen on, and that kicks off a server. Now, one important thing, Node doesn't auto reload your code, so we should probably restart it just to make sure everything's working. Turns out we actually have a syntax error. So let's fix that real quick because we didn't save the file after fixing the syntax error. We see the server is running again. And again, just for good measure, let's see that we haven't changed anything by reloading. And we see nothing there changed. As we called out earlier, this program did not stop running when it executed the last line of this file. And the reason it did that is because Node is a single-threaded event loop processor. It just processes events, and that's just what it does. It starts that up when we first run our file, like we did down here, and it stops doing it when two conditions are met. It has to run out of events to process, but also there has to not be the possibility that any new events could be generated. When we started our program, we started doing a bunch of initialization, and up until this point, we haven't done anything that could put new events into the event loop. That all changed at line 8. Node's HTTP server handles all the minutia of doing an HTTP connection. We just told it here to start listening for connections, to do so on port 1337, and when it gets a connection, call us back using this function. Telling a server to listen for incoming connections is an obvious source of future events, and that's why our program didn't exit here. So what happens then when we actually do get a request? Node calls back into our code using the handler that we provided, and it has these rec and these res objects. What are those? Well, we can read about them. Rec is an instance of http.incoming message, and res is http.server response. Now, in our handler function, we called them rec and res, but since this is just an arbitrary function, we could have been more verbose and called them request and result, or response rather. Or we could have called them foo and bar. Rec and res work because it's clear what they mean, so we stick with that. And then you can see how we use the things that are passed into here. For example, we call write head on res, which writes the response headers. And res end is a way to close the request and send the response back to the browser. And in this case, we're just giving it the text hello world. We didn't actually do anything with the request object, but there are some really good uses for that. One obvious one is using the URL and routing the request to the correct portion of our application. This particular application is pretty simple and we don't do that. One really neat implication of how this is set up that I want to call out, your request and your response objects here are not magically existent in the global namespace. They are actual objects passed into this function. Consider what that means for testing. If you wanted to test your actual request handlers, there's no wizardry you have to go through to make that happen. If you just mock up some sort of a request or response object and pass that in, you can very easily test your behavior without having to go through strange incantations that really don't make a lot of sense to people. And testing code is a really important thing to do, and this makes it really easy to actually test the code that handles incoming requests. So to summarize our program, what we did was we scheduled an I/O operation to happen in the background. And listening for HTTP requests, that is very definitely an I/O event. And of course, in this case, it could happen more than once. And we gave it some code to call back into when that event happens. That's the very heart and soul of what Node.js is. In this case, we used an HTTP server. That could have been a file read. That could have been a request that we made to an external service. But the point is that the actual I/O itself happened down in the core of Node, and we simply gave it code to execute when that I/O was ready for us to deal with it. This was a very simple and scaled down demonstration of how Node operates. Obviously, real applications would need to do more useful work than this, and we'll look at how to do that in the coming episodes. In closing, you might be wondering to yourself, this evented model, don't other programming environments do that too? And yes, they do. In fact, it even has a name. It's called the Reactor pattern, and Node is one implementation of that pattern. Where Node is different from things such as Event Machine and Ruby is that this pattern wasn't bolted on after the fact. Ruby was not originally an asynchronous evented execution environment. Node was. And where that gets you is that if you're using Event Machine, you have to be really careful about which libraries and external code you pull in, because while the actual Reactor itself may be evented and asynchronous, if you use a library that reads synchronously from disk, then you lost the whole advantage of having the Reactor. Node was built this way from the ground up, and you're much more likely to find Node modules that follow it, because if they don't, it would go against the whole grain of what Node is and be called out very quickly by the community. Well, that wraps up what turned out to be our two-part introduction to what Node.js is and a brief overview of how it operates. In the coming episodes, we are going to get more into doing actual work with it, and look forward to seeing you there. Until next time, happy coding. If you found this episode useful, or if it saved you some time, would you consider spreading the word by either sharing it on Facebook, or perhaps even tweeting it, or linking to it from elsewhere on the interwebs? Thanks a bunch.